हाँ जी, आ गया। थैंक यू। कितनी रजिस्ट्रेशन है हमारे पास?
सर 14। तो 3 मिनट है शायद।
2:02 हो गए हैं। आज डॉक्टर साहब का जरा इंट्रोडक्शन भी लंबा है।
अच्छा, पहले फिर इंट्रोडक्शन से स्टार्ट करना।
डॉक्टर साहब थोड़ा सा इंतजार कर रहे हैं। 26 बंदों की रजिस्ट्रेशन है और हमारे पास ये 26 जो है ना सीपीडी के लिए जो रजिस्टर्ड है, इसके अलावा भी लोग हैं, लेकिन जो रजिस्टर्ड है ना उसमें से अभी 16 आए हैं, 10 नहीं आए। तो मैं 2-3 मिनट और दूंगा और उसके बाद हम इंशाल्लाह शुरू कर देंगे। ये नॉर्मल है जी, 2-3 मिनट हमारे ऊपर हो जाते हैं। हमने आपका जो लेक्चर है वो 2:10 और 2:15 तक हमने लाजमी शुरू करना है। ये थोड़ा सा ग्रेस पीरियड है, ये जरा हमारे साथ थोड़ा सा बर्दाश्त कर लें। लोग हमारे नहीं आते टाइम पे, तो आई एम सॉरी फॉर दैट, लेकिन ये हमेशा ही ऐसे हो जाता है। Bismillahirrahmanirrahim. It is 5 minutes past 2 p.m. This is Pakistan Society of Civil Engineers welcoming you to lecture number 36. The topic today is basic consideration and application of self-consolidating concrete in Pakistan. Today's speaker is Professor Dr. Sayyid Ali Rizwan. Before I introduce the speaker to you, as a routine, I will just let you know what are the rules of attending this webinar. First, in case anything goes wrong technically with my Zoom application or the net, immediately Dr. Riaz Akhtar Khan will take over as the host. I repeat, if anything goes wrong, I get out of line, Dr. Riaz Akhtar Khan, who is present here, he will become the host and he will take over the charge. The rules of the webinar are that all the registered participants for CPT points have to appear live on the webcam. This is a rule set by Pakistan Engineering Council and has to be observed in any case. There is only one exception to it for the ladies, and that is, if they wish, they can cover their face, but they have to appear live. During the lecture, the microphones of all participants, except the speaker, shall remain in mute position. At the end of the lecture, there will be a question-answer session of 20 minutes. And during this session, question-answer session, you can ask the questions by typing the text or in your voice through the microphone. However, I have just talked to the speaker. He prefers that you ask him the questions during the lecture, slide by slide. The only limitation for asking the questions during the lecture is that you will have to type your question in the chat box, and I will read the questions as and when convenient to the speaker. That I will judge myself, and I will read the question with the name of the person asking question. This transmission is going live on the Facebook page of Pakistan Society of Civil Engineers. Sorry, my webcam was not on. I was pointed out by my assistant that the cam is not on, so I have switched it on. Thank you, Ji. So as I was telling you, that this lecture is going live on Facebook page of the society. So all the participants there, they can also ask the questions, but they will have to type. They will not have the facility of asking the questions through microphone at the end of the session. So this was about the webinar. I hope I don't have to intervene again and again during the lecture, which affects the flow of the speaker. So I would request you again and again that your webcam should be on, particularly for those who have registered for CPD points. And the microphones of all the participants, except the speaker, shall be in the mute position. Thank you. Now it is the turn I have to introduce the speaker. As I told you, today's speaker is Professor Dr. Syed Ali Rizwan. He is not a stranger to Pakistan Society of Civil Engineers. He has already given one lecture, I think, from our platform. His education is as follows. He did his BSc Civil Engineering from UET Lahore in 1976. Then he proceeded to Surrey, England, and to University of Surrey, and he did his master's from there in 1976. After completing his master's, he proceeded to Freiburg, Germany, and from there he completed his PhD in October 2006. Dr. Saab is currently a professor of civil engineering and Dean of School of Engineering in University of Management and Technology, Lahore. Before this, he has served on the following positions. He was a professor, chairman, Civil Engineering Department, and Dean of Faculty of Engineering and Technology in Superior University, Lahore from 2017 to 2018. Professor Saab was the professor of civil engineering and head of the Department of Structural Engineering, NUST Institute of Civil Engineering from 2008 to 2017. He was a lecturer, associate professor of civil engineering in UET Lahore from 1981 to 2008. Professor Sahab is a person who is deeply involved in the research. To his credit, to date, he has about 6 research projects, which are, I will name those projects. The first one is self-compacting pastes using super absorbent polymers. Second one is use of super absorbent polymers and Axia gum in self-compacting cementitious systems. The third one is CO2 reduced concretes using secondary raw materials. The fourth one is applications of self-compacting concrete in Pakistani infrastructural development. And the third one is a classified project, but I will just give you a hint. It's a rapid runway repairs. Then Dr. Saab has membership in American Concrete Institute, and he is a member of 3 important committees there. Dr. Saab, this is a class of your professorship, that you are the member of 3 committees in ACI. Then he is the peer reviewer of ACI material journals, Materials and Structures Journals USA, and Construction of Building Materials USA. He is also a fellow institution of Engineers, Pakistan. Publications. To his credit, are peer-reviewed 20 journals. Then he has 6 papers which are under preparation, and they are close to submission. And before starting formally, I was having an informal talk with Dr. Saab, and he said 4 have, out of this, I think 4 have already been published. Then he has peer-reviewed international conference papers which he has attended. They are about 88. He has organized 13 conferences, and there are 4 books written by him. I will just let you know which are the books for your benefit, for the benefit of young engineers. The first one is Theory of Indeterminate Structures, first edition, published in January 2000. The second one is Theory of Indeterminate Structures, second edition, published in 2003. The third one is Theory of Indeterminate Structures, third edition, October 2018. And then High Performance Mortars and Concretes using Secondary Raw Materials Cementitious Systems. He supervises the MSc Engineering dissertations. It's about 43. He has already done so far. I think whatever is written in his CV, he has at the moment 2 PhD students under his supervision, and he also works as an international consultant for civil engineering projects and projects and research projects, construction projects and research projects. So this was a very brief introduction of Dr. Saab due to the constraint and limitation of time on for us, because if this lecture extends beyond 2 hours, then we have problems with the space in saving this lecture and uploading the lecture on YouTube. So Dr. Saab, I'm really sorry I could not give a detailed introduction of yourself. Inshallah, some other time we will let the participants know what you have been doing and what you have achieved so far. Thank you very much for listening to me patiently. Dr. Saab, the platform is yours. Kindly start your lecture.
Bismillahirrahmanirrahim. I am really grateful to Engineer Tahir Sultan for arranging this lecture. This is my 3rd lecture for Pakistan Society for Civil Engineering, and I think the initiative by Engineer Tahir Sultan and his colleagues, especially Engineer Sohail Kibriya, Engineer Rizwan Mirza, and his friends, is commendable. They are spreading knowledge with a view that this country should make advancement in the field of civil engineering. So, with this brief introduction, I will start my presentation. I hope you can see the first slide. Is first slide clear to you?
Yes, Dr. Saab, mashallah, your voice is quite clear and audible, and we can see the screen sharing, your slides on the screen sharing. Thank you.
Thank you very much. So, in addition to ACI, I am also a member of American Society of Civil Engineers, and I contribute to the research articles in their magazines. One of my paper is likely to come up within a couple of months. It has been approved and now it is in the publication stage. Currently, I am the Dean School of Engineering at University of Management and Technology. And in addition to teaching, I do the overall supervision of 6 engineering departments. So these are the 4 publications which Engineer Tahir Sultan was mentioning. These have been published this year. First of all, optimization of effective microorganisms, modified cementitious composites cured at different conditions using Taguchi approach. This was the paper published in Journal of Cleaner Production. And then I had a paper on properties of self-compacting mortars using blends of limestone powder, fly ash, and zeolite powder in the Journal of Construction and Building Materials. Then this was a very unique effort. I had sent my student Usman Mahmood, who is now in Pakistan Navy, captain in Pakistan Navy, twice to Germany. So this was my approach, that the properties of concrete, that is in terms of viscosity and yield stress, can also be determined by imaging techniques. So for that, we had developed the idea, then apparatus, then wrote the software, got the apparatus manufactured, and now this was published in the ACI Material Journal, titled as Assessing Rheology of Self-Compacting Paste Systems, a New Approach. So, and 4th paper that is under publication stage is Sustainable Development and Performance of Assessment of Clay-Based Geopolymer bricks incorporating fly ash and sugarcane bagasse ash, because these are waste materials and we have to find their value-added use. So what is a self-consolidating concrete? This is the task assigned to ACI 237, and I am a member of that. ACI 237 defines self-consolidating concrete as highly flowable, non-segregating concrete that can spread into place, fill the formwork, and encapsulate the reinforcement without any mechanical consolidation. So from the definition, it should be clear. It is highly flowable. So in the fresh state, it acts as a like fluid, and the laws of fluid mechanics are available. Then in the transition, when the skeleton within the concrete forms, it is somewhat solid and somewhat fluid. And then after in that hardening stage comes when it gets hardened and obeys the laws of solid mechanics. So as you can see, that self-consolidating concrete does not require any mechanical vibration, which is normally done with the conventional concrete. What are the applications? Self-consolidated concrete is generally applied in situations where either mechanical vibration is not possible or it is uneconomical. The situations include tunnels, long span modern bridges, rafts, columns of high-rise buildings, pre-stressed concrete structures, transportation structures. And I hope that it will replace the conventional concrete in coming decade in the developed countries at least, and maybe after 2 decades in Pakistan also. Do you have any question on this slide, please? Okay, good. Now, what was the basic idea? The basic idea was from Japan. In fact, University of Tokyo, by Professor Okamura. He was of the opinion that when we vibrate concrete, the vibration, the degree of vibration or compaction depends upon the skill of the operator. And you know, the degree of compaction is not uniform throughout a structural member or throughout a structure. Therefore, he concluded that if degree of compaction is not the same, it means durability of the structure is also not the same. Therefore, he wanted to invent a kind of self-consolidating concrete which does not require any vibrations. And incidentally, in the early 80s, a quantum jump in the material engineering took place when the high range water reducing agents were manufactured in Japan and Germany simultaneously. So they were able to reduce the water demand by 30%. So if you consider the Abrams law of admixtures, water cement ratio versus strength, you know that as water cement ratio decreases, the strength increases, or vice versa. But when the water cement ratio decreases, workability problems they arise. So then these high range water reducing agents were invented, which allow us to work with very low water cement ratios or water cementitious material ratio, and yet have a lot of lot of flow. Okay, and SCCs does not produce any noise, because noise is a kind of pollution. Therefore, you can make concreting round the clock, even in a residential area, because in residential areas you cannot make noise in the evening. So now the question is, how do we get high deformation or flow? This is obtained by adding the chemical admixtures known as superplasticizers, written here as SP. What they do is that they produce electrostatic repulsion within the cement grains, or cement grains are uniformly distributed in the matrix so that the hydration products can grow and their network is more strong and durable. Now, all concretes, whether self-consolidating concrete or conventional concrete, it must have high segregation resistance, because segregation is a gravity-dependent phenomena. And in the concrete, if you look at the lightest material is water, having a density of 1 gram per cc, then fine and coarse aggregates having density of around 2.6 to 2.7 grams per cc, and cement has a density of 3.15 to 3.17 grams per cc. So if the viscosity of the system is not appropriate, then segregation will occur due to sedimentation or gravitational forces. And in that, the lighter material will come up, and we will have the separation between the phases. This is not liked because it adds to strength problems, durability problems. The other point is that SCC has ease of placement. You don't need to even level it, just place the pump. If you are using pumping, then the pumps can be placed at 5 meters intervals, and they can pour concrete, and you will get a nicely finished surface of self-consolidating concrete, which does not require vibration. And sometimes, if you increase the flow level, this can be also called as self-leveling concrete. Now, there is a slight difference between self-compacting concrete and self-leveling concrete. You must imagine that these two requirements of high deformation and high segregation resistance are of opposite nature. They are contrasting requirements to be met with a material engineer. If you have any question, you can get it noted. Now, in Pakistan, what is the current practice? This should be the question, and this is the main idea of informing young engineers why self-consolidating concrete is not being applied. So you must remember that, first of all, the architectural drawings are made, then structural drawings are made, and if in the specification it is written that concrete used will be a self-consolidating concrete, then only then it is bound for the contractor to use SCC. So at the moment, there are very limited number of structural engineers which specify SCC. Some of them may not know the advantages of SCC, or some of them may just ignore it because it has slightly high cost, because we have to have some mineral admixtures and some chemical admixtures. Chemical admixtures are imported from abroad. Mineral admixtures like fly ash is now available in Pakistan due to this thermal power plants. I hope that chemical admixtures will also be available, and then we will be very good in making self-consolidating concrete. So all this results in what is the current practice? Current practice is that people are using high slump conventional concrete so that it requires little or no vibration. But even then, you cannot compare its microstructure or the strength or the durability with the self-consolidating concrete. If you have any questions on this slide, please get them noted. Next. In all concrete works, it is very important to calculate the water demand of concrete. Maybe it is conventional concrete or self-consolidating concrete, because if you know the water demand of concrete, then your mixing water will be very close to the water demand of concrete. Now, you think, you know that in concrete, there is a powder phase. I mean, any material which is less than 125 microns in size is called powder. So cement plus fly ash or silica fume or whatever, they are called powders. Their water demand can be simply determined by using a Weichert apparatus. An experiment which you people do in your third year of civil engineering, calculation of water demand of cement. So then you can calculate the water demand of the fine and coarse aggregates. It is generally believed that water demand of the paste system is around 92 to 93% of the total concrete. So you can multiply that with the 1.07 or whatever to know the total water demand in kilogram per meter cube. So you can select an appropriate water cement ratio or water cementitious material ratio so that the water demand and the mixing water content are almost equal. Now the question may arise, what can be the problems if the mixing water content is less than the water demand of the system? Then then we will have these volume stability issues. Shrinkage will be a very big problem. And if you use water more than the demand of the system, then you may invite segregation, or if the viscosity is adequate, you might lose strength, because strength depends upon the mixing water content. So therefore, in my opinion, it is the first and the very important point to determine the water demand of concrete. Okay, then you should have a high flow and adequate viscosity, because otherwise you will not avoid segregation and you will not be able to produce self-consolidating concrete. Volume stability issues are related with the mixing water content. They are also related with the types of chemical and mineral admixtures. So a good material engineer who has been through all these experimentations in the laboratory, then at the plant, and then if he has some experience of applying self-consolidating concrete at site, only he can be in a better position to appreciate what happens when we test the same sample at these three positions. Mixing water temperature is very, very important. Water temperature, you know, water is a heat sink. People are not appreciative of its fact. In the winters, if you are using water, then it may be cold. In summers, if you are using water, potable water supplied by Wasa or whatever, it can be hot. Then the temperature of the concrete can be low or high. So that we have to keep in mind what is the temperature of the newly manufactured green concrete. That is very, very important. And then you have to determine the air content, because air is kind of void. More is the air content, then less will be the strength. However, having said that, there are situations in which we deliberately entrain air when you have freeze-thaw problems, because then it provides a kind of cushion in which these compressive strains can be accommodated. Placement technique is very important. If you are going to use a pumper, then you should know that during pumping stage, all phases, they have the same velocity. If the water has more velocity than the other phases, you will have separation and maybe the blockage of the pumping line. So to ensure the same velocity of all phases, you should be looking at the viscosity. Viscosity should be adequate. If it is low, then you might enter. And you must also know that after pump placing, all the pipes are water washed. Pipes are normally 4 inches dia steel pipes. If they are not water washed, they will have some concrete sticking to that. And if there is some concrete remains, then subsequent placements may be stopped, because that will be kind of an obstruction. Other consideration is avoid excessive shrinkage. Excessive shrinkage has many manifestations, and it has got many forms. If you keep on reading many books, you will be confused. What is plastic shrinkage? What is chemical shrinkage? What is autogenous shrinkage? What is drying shrinkage? What is total shrinkage? What is the role? Okay. So for that, you need to have some idea on different shrinkage mechanisms. I will throw a light on that also. Special curing techniques are used, as Engineer Tahir Sultan was mentioning. In some of my papers, I worked with acacia gum, Acacia modesta or Acacia nolitica, which is nothing but the gum coming from a plant known as kikar in local language. I have found it very, very nice to increase the viscosity of the system, and it also acts as internal curing agent, reduces shrinkage, and 4 of my papers published in American journals address this issue. The acacia gum powder is also used as a medicinal agent for the treatment of asthma and COPD and other problems. The cost is also a main consideration because some of the engineers are worried and they ask what will be the total cost. Now I ask them, how do you define cost? If it is the cost in the short term, it will be expensive because of chemical and mineral admixtures. But if you are asking about the long-term cost, then long-term cost of SCC will be less because it has a uniform microstructure and will be giving you a crack-free structure. So maintenance problems and the expense on that will be reduced. If you have any question on this slide, you can get your questions noted, please.
Dr. Saab, we have questions.
Yes, please.
The first question is asked here by engineer Hamza Ali. It's a question and observation also, both. Engineers on site, even on large scale construction, they don't bother to go for SCC. We know that it is economical and environmental friendly, but still major companies do not want to opt this technology. They think of it as dangerous as skilled labor is required for it. Why is it so? Why should not they move towards SCC and overcome their fear, because one has to take initiative to implement these in projects? Sir, you answer this question, then I will ask you the remaining two.
Okay. Hamza, thank you very much. I hope you have asked me a very contrasting question because, in the West, the cost is controlled by the labor component. And in SCC, you don't need to have skilled labor, just unskilled labor and a few of them, just to impart surface treatment. So why it is not being used? Because it doesn't come into the specification. Otherwise, there is no other issue. You don't have to have a skilled, labor to apply SCC. Another question, please.
Yes, sir. The second question is, these two questions I will just let you know together. They have come on the Facebook, and the name of the person does not appear in Facebook, unfortunately. So somebody has asked two questions. I think same person has asked two questions. One is, will vibration be required for SCC? And if not, then if vibration is done, what effect it will have on SCC? This is the first question. Second is, what is the optimum temperature of the water for self-consolidating concrete and the ambient temperature?
Yes. The most likely or most favorable temperature is around 20 degrees C of the mixing water content. And the other one I forgot, what was that, Tahir Sultan sir?
Sir, the ambient temperature, I mean, if the temperature of the ambient temperature is 30 degrees of the atmosphere, I mean, does it have any bearing on the strength of the SCC?
Yes. If the ambient temperature is more, then you need to have some mechanism so that the evaporation doesn't take place. Because if evaporation takes place, you can have the plastic shrinkage, which is not a desirable thing.
And sir, first question was regarding vibration.
Yes, I forgot. in generally speaking, theoretically speaking, vibration is not required in SEC. However, if you are making some typical structure like double T's, then it may be required by the site engineer or by the structural engineer to pour the stem with slight vibration, because stem will be, carrying forces from the overhanging flanges. Generally speaking, it's not required, but to be on the safer side, they might opt for slight mechanical vibration in case of double T's, which are used for parking garages.
Dr. Saab, thank you very much for answering the questions. I have to make one short announcement for the Facebook viewers. All viewers on the Facebook, please note, this transmission is primarily going on Zoom, and then it is linked with Facebook, where it is telecast for your benefit. So there is a lag of about 30 to 40 seconds in both transmissions. So kindly, whenever you post your question, be rest assured it will be answered. Thank you. Dr. Saab, continue, please.
Thank you very much, Tahir Sultan. Now, this is the next slide, which shows you how to make the flow measurements. In this slide, we can determine this is the Hagerman cones, and then we can have a target flow of 30 centimeters. So this can be used.
Dr. Saab, I'm sorry. Dr. Saab, I'm sorry. One question has been asked very late, but it is related to the vibration. So you answer it, then we can go ahead. This question is from Ziaullah, and he's asking, sir, I have been in literature, I have seen in literature that vibration, just a second, a vibration of about 20 to 40 seconds is required for compaction. So it will not cause segregation. He's just asking, will it cause segregation? 20 to 40 seconds of vibration?
20 to 40 seconds vibration is too much. It should not be done. Segregation will take place only if the viscosity is low. But if the viscosity is high enough, segregation is not likely to take place. Ultimately, due to sedimentation, all the phases will occupy their positions. But 20-second vibration, 20 to 40, is very high. You know, in the conventional concrete systems, the mixing time in Germany is around 2 minutes. And for special concretes like SEC, we can have 3 minutes to 3.5 minutes on the plant. So where you can discharge all the chemical and mineral mixtures in the same drum, and there is a lot of shear rate. Is
Dr.
that
Saab,
clear?
Yes, it is clear. Dr. Saab, a quick question has been asked by Dr. Suhail Raza. He is asking, Dr. Saab, you said 2 decades are expected before this SCC can be adopted in Pakistan. Why so? By what you have narrated so far, I don't see any hindrance in adopting it right away. No special equipment or technique needs to be implemented. Ji, Dr. Saab.
Suhail Raza, congratulations on being elected as PEC member. And I think if you don't see any hindrance, I also don't see any hindrance, but once it should get into the specifications, only then it can be applied. But if the structural engineer applies that the FC prime is 4000 PSI, slump is 2 inches or 4 inches, then how you can apply SEC? So you have to go for the change in the specifications. And I think PEC can take a role.
Oh, only, okay, Dr. Saab, you can go ahead. Just one correction. Suhail Raza is not a member of, he has not been elected as a PEC member. He's our colleague, he's of the same class to which I belong, Suhail Raza.
Okay,
Thank
okay,
you.
thank you.
Go ahead, please, sir, with the lecture.
So this is the Hagerman's cone for determining the flow of paste or flow of self-consolidating mortars. This is the mortar V funnel test, and this is the concrete V funnel test because the shape is V. We note the time that the concrete takes to get discharged, and you keep on seeing from the top. When you see a light at the bottom, you stop the watch. So that is the time required to empty the V funnel. So that time is specified at how much should be the funnel time to be classified and how much should be the spread. In case of SCC, we don't use the word slump, but we use the word flow. When you lift the cone, then the concrete SCC will flow in a circular form. Then you can determine the diameters in two orthogonal directions. The average diameter in centimeters will be known as the flow. And then this is the L box. L box is also used because here you have the reinforcements and you put the SCC here, you open up the gate from here, then SCC will flow. But here you will have three reinforcement to simulate the actual reinforcement in the construction. So the L box, L 20 centimeter time, 40 centimeter time, 60 centimeter time, and the ratio of the heights here and here is very important. That we know, that we note. You can record any questions on this slide, please.
Dr. Saab, please continue. There are no questions so far.
Okay. Now, as I have mentioned that in conventional concrete, the Japanese think and I endorse that there is a differential compaction and hence differential durability. In SCC, we have got uniform compaction and hence uniform durability. So environmental friendly concrete, no noise pollution, binders, powders, sands, chemical and mineral admixtures are important. The only thing that we should look for is that in case of coarse aggregates, the size and the content of coarse aggregate is slightly dropped. Because when this SCC flows, then there is an internal friction between different phases. And if there is more internal friction, it will take more time to flow. And hence, it will not be an SCC. Therefore, we choose a slightly low aggregate content, coarse aggregate content, and its size in actual practice can be limited to around 16 millimeters or so. In the conventional concrete system, if you are doing residential buildings, these days engineers prefer to have a half-inch down concrete. But when I was a student at UIT Lahore, then our teachers like Professor Khilji and others, they used to tell us that the maximum size, the course of aggregate size should be as maximum as possible. Even they recommended 1 inch and 1.5 inch. But later on, when these imaging techniques like scanning electron microscopes were invented and applied, it was evident that if the size of coarse aggregate is high, the thickness of the interfacial transitionary zone will be more, and that is the weakest link in the chain of reinforced concrete structure. So we want to have a smaller sized and a slightly lower content of coarse aggregate. Then I will try to show you some videos. I'm not sure why these. This is the L box. You can see these reinforcements and concrete is flowing. So we determine the 20 centimeter, 40 and 60 centimeter time. And this is V funnel test. You note down the time to prime the V funnel is now. This is the slump cone test. The Germans keep the bottom end narrow and down because they think that they don't need anybody to support it. This is me when I was doing PhD. So you can see my. Now this is the J-ring test. And these reinforcements, they simulate reinforcement or the obstruction to the flow. Ordinary slump cone. Now all these will indicate that there was adequate viscosity. Otherwise, some coarse aggregate would have gone apart. Then in this picture, you can see some of the powders which can be used in Pakistan. In Pakistan, we have got this crushers available near Margla stone, and the dust of that is called limestone powder. I have labeled it as LSP. Then fly ash is also available due to these thermal power plants. You can also use rice husk ash if it is amorphous, and you can also use silica fume as the powder. These are the mineral admixtures. They improve the microstructure of concrete. Now, I wanted to show you in pre-stressed concrete structures, you can use SCC.
This video will explain the entire process of using a pre-stressed concrete and a pre-stressing plant. In this case, a double T. A double T is used primarily for constructions, but can be used in virtually any type of building, including office buildings, industrial buildings, and schools, to name it. Double T's are kind of make these products that span. Long spans, like 6 plus, and something heights 120. The typical pre-stressing plant usually starts very early in the morning. The product from the previous day's past was pure and the pieces being stripped to get ready for today's person. For any pre-stressing plant, it is very important to maintain not only positive from an image standpoint, but also from a safety standpoint, since any debris that might be left over from the day before could create contributions or other safety problems. The first part of the process is setting up of the form. A thorough cleaning of the entire form is done with basic liquid cleaning equipment. Setting aside forms, or in the case of a typical double T, the forms may be mixed forms with an appropriate draft to allow for easy stripping. Once the bed is clean, it's ready for setting up today's cast. This particular bed is set up for 5 double T's, each about 60 feet long. The bed has a total length of 400 feet. This is a self-stressing form, where the form itself is designed to take the total pre-stress force and compression, and also to handle the eccentricity of the strings. Sometimes the producer makes a form that is set between both ends that are built right into the ground. The pre-stress force is then resisted entirely by both ends and the both ends. Next, the strings are placed in the form and extended from end to end. Let the strands through each of the dividers, and then run the stressing plates at each end. The typical spacing of the strands is approximately 2 inches. This divider is a steel device that separates the individual double T units from one another. A gap of about a foot is typical to units of the adjacent piece. This gap is required so the frames can access and cut, and that each double T can be stripped from the forms. The next step is the tensioning of the strands. In this case, we have a strand and straight strands of 6 strands at each stem, as shown here. The strands are first tensioned to about 2 to 5 pins based on the gauge pressure reading. In this case, a mark is made on the strand after the preload is applied. The strand is then tensioned to the specified level and is measured using gauge pressure on the hydraulic pump. The QC technician then checks the elongation against the theoretical elongation. The requirement that is the force on the gauge and the elongation must match within 5%. If that tolerance is not achieved, the reason must be established and the strand may have detention and retention. After the strands of this double T are all stressed, the remaining bends are set in place. These include stem reinforcing, particulars that can be used to strip and tear. Forms for blockouts in the flange and forms for blockouts in the stems. Flange reinforcing and flange connectors for connectors along the end. In this case, one of the double T's of the bed has typical flange is applied along one edge and special flat plate connectors applied along the other edge to accommodate connection force and its being. The form is now ready to have concrete, but only after a pre-or quality control check is made and the QC person signs it. This QC check can also be done by the bed superintendent. That depends on the particular plate's practices. The check is critical to ensure and product the highest quality. There's all these things you look like a bad shot, look ready for touching, stamp, bottom, wire tight, like telling that, you check the lane, you want to make sure that the tap is correct. Strip properly. So there are a lot of regulations. Concrete is mixed in the batch blend under tightly controlled conditions. The cement is supplied using tanker trucks. Here the cement is flowed from the tanker through piping to the cement site. When needed, aggregates are delivered to bins in the batch plant. The aggregates are stored outside of the batch plant in separate bins. In this case, an enclosed vertical bin system is utilized. During winter, in northern climates, the aggregates must be heated together properly through the batching system and maintain proper concrete mix temperatures. Aliens are used to shuffle the surface to protect the hole. Computers are used to proportion cement, sand, stone, water, and wind are measured according to signals from the computer. After the concrete is discharged into a delivery device, it's imperative that the concrete mix be delivered to the form as soon as possible. These vehicles are called tuckers, and they are used to deliver the concrete to the yard. A self-consolidating concrete is being used to cast these particular double teams. With this type of concrete, vibration is not required to consolidate the concrete. However, lighter controlled vibration is used in the double T stems to help repair from the side.
So you have seen the that the stem was slightly vibrated because in double T's it matters, but the vibration time was just a few seconds, not 20 or 40 seconds. Then in the SCC plant, I had a chance to work in the team of professionals in Germany, where we had to make concreting at 150 meters down the ground surface, and the horizontal distance was also around 300 meters. The pumper was used. The pumper was from Putzmeister, the best pumper in Germany. And then the natural aggregates were used. The maximum size of aggregates was 16 millimeter, but if you can see, some of the aggregates were
Just go straight to
5
the
centimeters long, but they could have passed from the minimum dimensions. So if you get more of these particles, then the chances of blockage are quite a lot. So you should be careful about the paste content, because in such cases, paste is the vehicle for the transport of aggregate phase. So you have to examine the shape and size of the coarse aggregate. This elongativity index should not be more than 5%. Otherwise, you will have some blockage problems. If you have any questions, please get it recorded.
There is a question.
Yes,
This is from Hazik Zahir. He is saying, sir, if I am not wrong, these all LSP, RHA, SF, etc. are pozzolanic in nature and improve the gel matrix formation of cement paste in SCC. This is the question.
yes. Most of the powders used are pozzolanic in nature, but he should remember that some are not. Like limestone powder is an inert material, but it has been found that it offers some nucleation sites where the hydration products, they fall preferentially. So we use limestone powder sometimes in combination with fly ash because of the synergy in that. So I will advise him to read my paper on the blends of limestone powder and fly ash. They improve the performance of self-consolidating mortar systems. It was published in the Construction and Building Materials. Any other questions, please?
No, Dr. Saab, please go ahead. No other question.
Now, this is the simple slide which shows how to calculate the water demand of the system. Now, one question should be very clear, that as a material engineer, you must decide yourself what should be the ratio of the powders, the secondary raw materials or supplementary cementitious materials. For example, if I use that cement will be 1 part and fly ash will be 38.7% of that. So I mix them together and then I attach them to Weichert apparatus and determine the water demand of the system. the content in SCC will be 380 plus 147. If cement is 380, then this will be 380 into 0.387, 147. So total is 527. You can determine the water demand if it is comes out to be 27.5%. You multiply this with that, you get 145 kg per meter cube. So you can see a lot of water demand by the powders. Then I determine the water demands of these aggregate sizes according to ASTM standards. So, and you can in fact add them together, and the total water demand of the system was 167.5. So I chose a water cement ratio of 0.45, which gives us a water of 171 kg per meter cube. Because I told you that the water demand, the mixing water content should be very close to each other. It should not be very far from the demand, should not be very less from the water. Okay. So this is a very simple method. Although in Germany, one girl was known as Betonkönigin. It means that queen of concrete. She devised a special method to determine the water demand of concrete systems, and it was quite complex and not field oriented. So when I applied this method and compared with her results, the difference was only 1 to 2%. So you can do the Vicat test at the site. There is no problem. Okay. So I believe that technology should be simple and it should be adaptable to the field conditions. You can get your questions noted if there is a question on this slide. But this paper was published in BMC8 Warsaw, Poland, and it was on page 152. The reference is given. Then this is very beautiful slide, which gives the packing concepts in high performance concrete or self-consolidating concrete systems. This has been taken from a journal. Probably this was by Professor H.J.H. Browser from Eindhoven University of Technology. You see on this, there is the void fraction. If there is a 0.4, you can call it 40%. And here is the percentage of coarse sand to coarse aggregate. So as a field engineer, simply by inspecting this graph, you can decide what should be the ratio of the sand and the coarse aggregate. This is unconsolidated loose and this is eroded. So you will agree with me that between 40 to 60 or 50 to 50, 50% sand, 50% coarse aggregate in different sizes can give you the lowest void fraction. The lowest void fraction has an importance. What goes inside the void? Inside the void, there can be either air or water. So in a modern concrete system, we want to pack the concrete system as far as possible. So that is why we are having problems like shrinkage and other things. These were not the problems with lean concretes because they had very high void ratios and very high internal cushions. So if modern concretes are used, they give some advantages, but you should be very well aware that you can be in problem if you do not know how to handle them properly. So this is a very beautiful picture. I like this picture, so that is why I inserted it here in my presentation. And I think more work can be done to improve these using our Pakistani sands and coarse aggregates, because after the construction of dams, according to Indus Basin Treaty, the water coming downstream is actually sediment free or very low sediment or very light size. So the result is that the fineness modulus of sand has been dropping over the years. Now the highest fineness modulus of sand is from River Harrow at site Kibla Bandi. That has a fineness modulus of around 2.2. But we all know that in order to make high strength concrete, we need a sand of fineness modulus of around 3. So we need to mix the coarser fractions in order to make high strength SCC or high strength conventional concrete. If you have any question, please get it noted with the Tahir Sultans. Then in this slide, which looks very beautiful, on the vertical axis, there is the air content.
Dr. Saab, we have a question.
Yes.
This question is asked by, again, engineer Haziq Zahir. He is asking if SCC is to be made as high strength, water content will automatically have to be reduced and maybe use some super plasticizers for compensation. Your comments on this?
Yes, Haziq, I agree with you. Even in conventional concrete, these days we use super plasticizer. In case of self-consolidating concrete, you cannot make it self-consolidating if you don't use super plasticizer, because high strength will not be produced. So if the target is strength and flow is also too much, you need to know, you need to use the high strength water reducing agents or super plasticizer. I have worked to water cement ratio as down as 0.2, and yet it had a lot of flow. But the only problem was that I was entrapped in, shrinkage problems, and then slump retention was the main problem. Any other questions, please?
Dr. Saab, go ahead. No other question, please.
Thank you, sir. So in the vertical axis, there is an air content, and on here, I have used 4 different types of grading: G1, G2, G4, G6. Probably this is 50-50, 50% coarse, 50% fine sand, and this is 55% sand and 45% coarse aggregate. So as you increase the quantity of sand, you will increase the entrapped content as high as 2.3 or 2.4, even in self-consolidating concrete. So sometimes this picture can be taken advantage of, because in the areas, if you want to make concrete in freestyle area, so you want to have more air content, so use more sand. I mean, G6 with 55% sand and 45% coarse aggregate will be ideal. It will require less air entraining agent, and then you will be making an economical concrete which is resistance towards freeze-thaw problems. And many other conclusions can be drawn from this picture. This also appeared in some of my papers. If you want to have any questions, please get it recorded. Then comes, the measurement of shrinkage. I have determined the measurement of shrinkage with cement and limestone powder, and this is in the covered conditions, this is in the uncovered condition. So you can see with different types of cement, SAM 1, SAM 2, SAM 3, this is the European terminology. SAM 2 was having 6 to 14% limestone powder, and SAM 3 was the blast furnace slag cement. You know, in Europe, in all the marine structures, SEM3 is preferred because short-term strength is not the target. The actual target is very low pore sizes. And the
Dr. Saab?
microstructures, yes,
I need to make a short announcement. I'm really sorry
Yes.
for that.
yes, please.
This is the first time that we have got a foreign national on Zoom, and the lady is from Jordan, Lubna Al Khawalde. So, sister, welcome to this forum, which is of Pakistan Society of Civil Engineers. And every month we have a lecture. Whenever you wish, you are most welcome to the forum. Thank you, sister. Sir, continue, please.
Thank you for having me. I'm so blessed to have this meeting. And you have it every month, you told me?
Yeah, inshallah, next time again I will invite you. Thank you very much.
Inshallah.
Can I continue?
Ji, Dr. Saab, please continue.
So this slide shows you the effect of covering the self-consolidating system, because covering stops evaporation. So evaporation is the main mechanism associated with the plastic shrinkage. And at the end of the day, you will find that all these three cements give you almost the same shrinkage in both covered as well as in uncovered conditions. So in the very early beginning, this cement seems to give me, high early strength because it is SEM2. Then SEM1 is here. This is SEM3 because it has 70% blast furnace slag. Its setting will be late. So you have to address all these issues by experimenting with all the supplementary cementitious materials. I experimented with limestone powder, then I experimented with fly ash, then I experimented with silica fume and the combination of these aggregates. You can have a look at my thesis. Just type on the Google thesis Rizwan and you can download my PhD thesis. Although it will look simple, but in PhD you have to tell us a story starting from the base and converge to a point. But don't assume that only that work was done. The work done was too much, which I am publishing now. Now moving on to this slide, there is a tendency in Pakistan to use silica fume because engineers have somehow found out that silica fume gives strength. The answer is yes, it gives strength, but it has some other properties. It will increase the hydration kinetics. It will absorb the water. You can see these are the carbon particles, which may be 0.5% in silica fume. And you can see these channels. These channels accommodate through capillary action some water which is not retrievable into the mix. So that is why silica fume acts as anti-bleed agent and it gives you a very dense structure. So before you use silica fume, please try to note that if you use it in summers, where the temperature, ambient temperature is 40 degrees, please do not use it during the daytime. Use it in the nighttime by observing all the conditions for hot weather concrete. So you should be well versed with all the typical associated problems. Next slide. Now this slide, I was testing a self-consolidating mortar, and then this is the aggregate. You can see the aggregate under scanning electron microscopy. It has been magnified by 300 times. This is the matrix, and you can see a very well-defined ITZ. This is the zone which separates aggregate with the cement paste. Okay. Now, these days, we are busy in making some arrangements how to make this ITZ very strong, because this is the weakest chain in the link in the reinforced concrete structures. So that is why we are using a low size of the aggregate, okay, to have this ITZ as small as possible. There are other ways also. Please book your questions with the moderator, Tahir Sultan Saab, if you have. Then you know, all the civil engineers, they know these are the hydration products, very well defined, hexagonal, beautiful calcium hydroxide crystals, calcium hydroxide, and these are the tringites. The shape and the morphology and the sizes are changed due to some constituents. So we have to study the microstructure, assuming that the properties at the microstructure will be explained at the macro level. So we test microstructure and then explain the results at macro level. If you have questions, you can book it with the Tahir Sultan Sahab. Now this is the calorimetry curve. In which I have just tried to use.
Dr. Saab, two
SEM1.
questions.
Okay, good. SEM1 and 40% water is black. So this is SEM1 paste with some super plus sizer.
Two
This
questions,
blue.
Dr. Saab. We have two questions.
Yes, please.
The first one is again from engineer Haziq Zahir. He's asking, sir, are there any detrimental effects of using SF? Literature usually suggests a use of 10% of quantity of cement in the mix. And the second one is related also, that I will also just read out. Sir, what about heat of hydration relatable to SCC? And also when we use pozzolanic cementitious materials with SCC, are they act as retarders also? Because there seems to be a delay in setting time. Kindly answer, Dr. Saab.
Yes. In silica fume is a kind of accelerator. If you see these present investigation, you will see that he is right, Haziq. I think according to my experience and testings, the maximum quantity of silica fume or rhesus ash or fly ash which should be substituted for cement is around 10 to 15%. For silica fume, 10% seems to be a reasonably good value. So all pozzolanic materials are in fact accelerators. They increase the heat of hydration and the reaction of hydration. For example, if you see this graph only, in which I have replaced 10% cement with silica fume, you can see it has got very much high heat generated. Why heat has generated? Because of the chemical reaction. It means that it has expedited or it has accelerated the hydration kinetics compared with the rhesus ash, which is equally pozzolanic. And you know, these two curves are almost lying one over the other. So similar to silica fume, I think all should be doing the same, except that fly ash gives its pozzolanic activity after 14 days. I mean, after 14 days or 28 days, it gives you very high strength compared with the initial 7 to 14 days. But silica fume, right from the very beginning, starts giving you very high strength. The only precaution is that you must know the temperature of the resulting concrete which you make. And in the lab you can test, in the field you can test, and then you can decide the time of placement. You can place at the night.
Doctor, one more question.
Yes.
This is from engineer Ahmed Raza. He's asking, sir, what will be the acceptable value of true slump in flow or slump test?
I think the question is confusing. The slump test is different. Flow is for SEC. Slump is used for conventional concrete. The true slump, the value of the slump for conventional concrete may be in the range of 4 to 5 or 6 inches. For SEC, there should be a spread of around 70 centimeters. Although in the literature they say that at 66 centimeters, it will be treated as self-consolidating, but I think it should be 70 centimeters spread. Any other questions, please?
No, sir, continue.
No, admixtures are added to concrete during mixing or placements. These may be mineral admixtures or chemical admixtures, or we use both. Mineral admixtures may be fly ash, silica fume, ground granulated blast furnace slag, rice husk ash, wheat straw ash, limestone powder, and bagasse ash. So if you go through this list, I think we can use some of them. I have supervised MSc theses on all these supplementary cementitious materials, and now I plan to write a book on the local supplementary cementitious materials, which can be used in high strength, high quality concrete. Then chemical admixtures can be superplasticizers, viscosity modifiers, and air entraining agents, accelerators, retarders, etc. If you have any question, you can get it noted, please.
We do have a question.
Yes.
This question is from engineer Hamza Ali. He is asking, sir, when we use these pozzolanic materials, initial or early strength is high, but later ultimate strength is less than other.
Not necessarily. I mean, when the first peak comes, then he is right that the later on strength may be slightly less, but again, there will be, you know, he's referring to this graph, that initially high early strength and later on this is that. But that doesn't mean that after 72 hours, this pozzolanic material will die out. Silica fume will produce third peak, and that will be higher than that. So this will continue doing that.
Yes, we have another question from Haziq Zahir. He is asking, does SF enhance the early strength of concrete, say up to 28 days only? Maximum testing is carried out at 28 days. Or does the use of SF also extrapolate in the strength?
Yes.
Extrapolate in the strength development in the long term too.
Silica fume enhances the strength both in the short as well as in the long term if treated properly by a well-versed material engineer. Any other questions?
Please go ahead, sir.
Then you have to consider the surface moisture conditions on the aggregates, because in the natural pit, they can be oven dry or they can be in the air dry. There can be some water, or in SSD condition, all voids will be filled with the water, but there will be no extra water on the rim of the aggregate. And in the wet, you can see this extra rim. So in this case, this oven, if you use oven dry coarse aggregates, it will take water from the mix to complete its dryness. Even air dry aggregate will also suck in some of the water from the mix. if you use coarse aggregates in SSD condition, they will not contribute any water to the mix, nor they will require some water from the mix. In wet conditions, the aggregates will give away some water to the mix. So we should be very particular. If the aggregate is wet, then there is a method that you can approximately calculate how much is the wet water, or how much is the water more than SSD conditions. So reduce that much mixing water. Questions?
Continue, sir. No questions.
You know, I was also interested to make very high early strengths cementitious materials. For example, if there is a motorway, or there is some damage to the motorway, then we cannot close the motorway for 28 days. So what we should be doing that we should devise some technique how to restore the traffic as soon as possible. So in this case, I have tried to restore the traffic in 30 minutes, and then I achieved the strength of 4,800 psi in about 1 hour, and then it gave us a complete bond with the rest of the damaged structure, and then gave us a very nice finish. So the grouts can be used, self-consolidating grout systems can be used to make these kind of repairs. But there is only one thing, that initially they give you a lot of shrinkage. So in the recipe, you should have something which acts against shrinkage. I mean, you can use something which encourages the growth of ettringite or growth of calcium hydroxide, or you can use some chemical admixtures for arresting the or compensating the shrinkage. So it is possible for us to repair these strategic structures in a very low time, according to the client's requirements. If you have any question, please get it recorded. So you can see that in some formulations, after 24 hours, I was able to obtain a strength of 50 megapascal. 50 megapascal, when you multiply it with 145 or 150, so that is a lot of strength. So all these green and blacks, they are the good candidates for high early strengths. But of course, in this case, I used a blend of cements. Calcium aluminate cement was used, and OPC was used. Some accelerator was used. Some retarder was also used. And I had to pack all the structure. If you have any question, please ask through moderator, please.
Continue, sir. No questions so far.
Then resistance to segregation can be determined by sieve stability segregation, a test apparatus like this, or a static column segregation. In that static column, you make a column of a given height, fill it with the SEC, then after 24 hours or after 2-3 days, you can remove it. You can make the length comparison and the weight comparisons, and then you can cut these in 3 pieces. If you find the density of all these 3 pieces same, it means that the coarse aggregates are evenly distributed at the top as well as at the bottom, and there is no segregation. So this is a very simple test which is visually available, visually acceptable. You can see that coarse aggregates are available at the top as well as at the bottom. To confirm it, divide it into 3 portions, weigh the 3 portions, and if weights are same, that it means that there is no segregation. There are some slump law cases which can be cement superplasticizer incompatibility. The other things is if you are using more than one chemical admixture, it is advisable that you should use all chemical admixtures from one company. If you are using superplasticizer of one company, air and training agent from other company, accelerator another company, you will end up in incompatibility issues. You will spoil the placements. Okay. Then you can have the increase of zeta potential of C3S phase. So why we are concerned with the 28 days FC prime? Because a cement clinker generally has 4 phases: C3S, C2S, C3A, and C4AF. Only the hydration kinetics of C3S phase have been fully understood, and it is believed that whatever is the strength of C3S at 28 days, that will be the strength of mortar or concrete. So we are basing our calculations on the achievement of strength by C3S phase. C3A phase can do some other things like imparting alkalinity or other than that. So if C3A is more than 10%, then the maintenance of slump can be a problem. And C3A is if higher, it can have higher shrinkage also. If there is question, you can get it noted. No, the aggregates are examined according to ASTM standard C295 and done from the queries to know that whether there is a chance of alkali aggregate reaction or not. Thin sections can be tested under the microscope. Then the ASTM also specifies mortar bar test and accelerated mortar bar test to investigate beforehand if there are some reactive aggregates or not. Okay. A quick chemical method according to ASTM C289 can also be performed. So you can perform any of these tests to ensure that the aggregates are not expansive in nature. They don't expand, because if they are used in hydraulic structures or other structures where moisture is present, then they will produce a kind of internal gel which will expand and crack the concrete. So this must be done. Modern concrete has high strength and low water cementitious material ratio. Usually we use both chemical and mineral admixtures. Strength level is high, slump is high using high range water reducing agents. Microstructure is improved. Shrinkage is a problem you should address. Serviceability may be a problem if the member sizes are slender. Then porosity and threshold pore diameter is less and easy placement. So in general, if you test a high strength concrete cylinder, then it should explode like a cartridge in the shotgun. And you can also, in a displacement controlled machine, you can also listen the internal cracking. You will notice that internal cracking, internal phases are cracked while there is no crack on the external surface. So, but when they will explode, I mean, they will explode very, very strongly. I think we have done that. These are some machines which are used. This is the mercury intrusion proximetry. This is scanning electron microscope, which I used in Germany. You know, these are the places where you can hold samples. And this is the software by using which you can determine the shrinkage of a cementitious material placed inside these samples. These are the covered samples. By covering, you tend to evaporate, to avoid evaporation and reduce shrinkage. So these are some visual effects. This is the, I went on at a solar plant. So Germany is very famous for making solar panels, although they are very expensive. I have spoken about the anti-bleed agent of silica fume. This was the tunnel that we produced 150 meters below the ground level. And in that case, a SCC duct was placed here and pumping was done from the top. Very beautiful structures have been built using self-consolidating concrete. In my opinion, everything is possible in modern concrete system if the user is well aware of all the positive and negative points of all the constituents of aggregates. Any questions?
We have a question from Rizwan Mirza.
Yes, it is 1 minute.
He's asking, rather stating, it could be wrong, but the cylinders shown in an earlier slide to represent low density concrete. Is that correct? Do you have
No.
a record of the unit weights?
Yes, they are of high density, 150 pounds per cubic foot. These were taken from the SCC which we used in the tunnel in Germany. And they were very high strength concretes. I was given a call by engineer Azhar Ali Bhatti, and he said, Rizwan, can you improve our FC prime by, let's say, 2000 PSI? We make pre-stress concrete members at 5000 PSI. I said, yes. I have made self-consolidating mortar systems having FC prime in the range of 28,000 PSI. If you make it 7,000, 8,000, your product will not sell because the end user is not aware of the benefits. End user is concerned only with the cost. So if your company produces high strength members, they will not sell, some other company will take advantage. So this depends. If the user is aware to pay for the quality, only then such high technique materials can be applied.
Thank you very much, Dr. Saab. A wonderful, informative lecture. Now he is finished with the Dr. Saab is finished with this lecture. Now we have time for question answer session. If anyone wants to ask question, either he can type it or he can ask via microphone. So I am waiting. If anybody wants to ask question, he is most welcome, and just raise your hand, then I will call you to ask the question. I think a lot of questions have been asked during the lecture. So rather, most of the questions pertinent questions have been asked already. So let me see if anybody raises his hand for questions. Well, I think, Doctor, looks like we are done with it. There are no more questions. So, yeah, we got it. One we got again from, it is from, this is from Hazid Zahir. He is asking, please provide some brief details about 2,800 PSI concrete.
2,800 or 28,000?
2,800. He's
2,800 is a lean concrete. That is not a structural concrete. I was mentioning that I made
no, I think
self-consolidated.
he has clarified. Now it is 28,000.
Yes, he should just type on the Google thesis Rizwan. And then he will get PDF format of all my thesis and look in the chapter of self-consolidating mortars and get the value himself.
Okay, that suffices a detailed answer. So, Ahsan Javed is asking, sir, as you mentioned that you created 28,000 PSI concrete. So can you please guide us? Is there any mixture used, any specific admixture?
A lot of admixtures, lot of packing concepts, lot of shrinkage reducing agents. So it was a very comprehensive study. I mean, to reach at 28,000 PSI. All are given in the thesis. He can look at that. In the Google, he has to type thesis Rizwan, download my thesis, and then he can correspond with me through you, or just write and try to send me an email at sayyidalirizwan@hotmail.com. I should be pleased to answer all the queries.
Yeah, I should thank Hamza Ali. He has already typed your email in the chat box for everyone to see. So I repeat it, it is sayyidalirizwan@hotmail.com. Thank you, Hamza Saab. You
Yes.
did a good job. So I don't see any further hands raised, or nor I see any questions. So it looks like now, as I say, we are done with it, then a question props up. So let me make sure that there is no further question and we are
Yes.
done with it. Yes, sir. Now we are done with it. If there are any further questions, you can contact Dr. Saab directly on his email, which is in the chat box for everyone to see. It is sayyidalirizwan@hotmail.com. And in case you have any difficulty in accessing to Dr. Saab, then you can send your email to Pakistan Society of Civil Engineers, and there we will take care of it, and we will make sure that it reaches Dr. Saab, and he will be very pleased to answer your questions. So now we come to the end of this webinar. I hope you people have enjoyed it. I really enjoyed it, and it was full of knowledge. So this is the purpose of Pakistan Society of Civil Engineers. to impart knowledge, to present knowledgeable, experienced speakers before you who can really impart knowledge to the civil engineers of Pakistan and abroad. So, Dr. Saab, thank you very much for such an informative lecture, which was
Thank you very
technically
much, Tahir Sultan Saab. I'm thankful to you, thankful to Rizwan Mirza. And if Sohail Kibria is also listening, I'm thankful to all my colleagues. I respect you all, and you are doing a wonderful job. Thank you from my side.
You are most welcome. Hasnain Safdar Saab, you have asked to share a copy of the presentation. For that, after a few hours, this lecture would be uploaded on our YouTube channel. From there, you can view the lecture, listen and view the lecture on our channel. And I think it will also be same time, it will also be uploaded on Facebook page. From there, you can also view the lecture. So this is all free. I mean, all the stuff which is available on our YouTube channel and Facebook page, this is all free for everybody. So far, it is free. So again, Dr. Saab, I thank you very much. Now I have to make a couple of announcements. Dr. Saab, your shield and your certificate, inshallah, Mrs. Sadia Naveed will send you by the courier mail. It will reach you, I think, within this week or earlier within the coming week. And for the participants, the next lecture is on 11th of December. The speaker is Dr. Zahir Malik, and the topic is brief overview of the design concepts of concrete rock-fill dams. So this time we are changing the subject. We are drifting from the concrete and the structure. We are now going towards the dam. I repeat, the lecture is on 11th of December. The speaker is Dr. Zahir Malik, and the topic is brief overview of design concepts for concrete rock-fill dams. The registrations would be open from Monday, coming Monday onwards. You can start registering yourselves for this for the next lecture. The certificates of today, CPD certificates, would be available for collection from our office located at 83M Model Town Extension, Lahore, from 17th of November onwards. And you can collect them from Monday to Friday during the office hours, which are normally 10 a.m. to 4 p.m. So I repeat, you can collect your certificates from 17th of November 2021 from 83M Model Town Extension, Lahore. If you want to note the phone number, it is also, the cell number is available, 0345 424 3404. And this is all what I had to say. And Dr. Saab, thank you very much again.
Thank you very much, sir, for inviting me. And I hope to continue with you. Whenever you want me, I will be at your disposal. Thank you very much.
Thank you very much, Dr. Saab. All participants, I also thank you for joining our platform here for lecture number 36. Now we come to the end of this lecture. Thank you very much. Allah bless you all.